the potential energy of a spring, and how to write the expression and how it is derived. Let's see this in this class. You know very well that the force of a spring, the force of a spring is conservative force. How? Let us see that. Of course, the force which is also seen as variable force. Variable force means which is varying with position, right? Now, for this we consider a spring, a spring, a spring of spring constant, we will call as a spring constant K, or we will also write it as force constant, which refers stiffness of the spring, stiffness of the spring, right? Now let's see that how the spring is resting on the table and how the force is applied and how it is restores its energy. Let us see that. So this is a surface, this is a rigid wall, right? Now this is a spring which is attached to rigid wall and attached to a block of mass, of course, which is called as unapplied position. Force is not applied here. Now this is called as M, right? Now this is a fixed position. This is also called as a mean position, mean position. At this moment, so this mean position, force is 0 at this moment. Actually we are not applying force. Suppose if this is being pulled and displaced, this is being pulled on right side, we apply force. This is because of displacing, which is due to applied force, applied force. Now what happens? Of course this is x position is there, the spring is trying to pull back and come back to its original position, right? So this is called as a force of spring. In this direction we had force of spring, and this is called as force of applied, and it tries to bring back its original position. So displacement is right side, the force of spring is left side. So as long as the position is increased, the force of spring is also increased. So shall I write it as if proportional to x but in negative direction? If I remove the proportionality, which is called as minus kx, here k is called as spring constant, spring constant, right? If k is large, stiffness is more. If k is less, we will refer it as stiffness is less, right? Now, how to write this one? Let us say minus F by x. What are the units for spring constant? Newton per meter. Newton per meter. Right? Now, as the we are interested to calculate work done by the force, how much work done by the spring as we apply the force. Of course, if you write like this, this is proportional to x and F is equal to kx. This is called applied. This is a spring. Why I am specially mentioned this is a spring. Do not be confused with this. As this is a varying force, how to calculate work done? When we want to calculate work done by the spring, means definitely we should use integration a force of spring into the displacement which is being corresponded. It starts from 0 position and going to maximum displacement from the mean position, right? Now the work done by the spring is equals to integration minus kx dx 0 to xm, right? Now we will take it as k outside x dx 0 xm, so minus x square by 2 0 to xm we should write it as, right? Work done by the spring is equal to half kxm square of kx m square. This is work done by the spring. Negative is there, don't think that it negative means it is less than 0. It represents work done by the spring, right? Now how to represent in a graphical manner and how to calculate this? Now similar case we will expect other way. Again wall is there, the spring is there. This is m x is equal to 0 position, right? Now if it is being compressed, compressed means we are applying force on this. So this is m where a spring is compressed. Now mean position means which is x is less than 0. Now what the spring is trying to do? The spring is trying to extend itself. So this is called as a force of spring. Now force of spring is right side, displacement is left side. Force of spring is right side, displacement is left side. Again I should write it as a force of spring is directly proportional to x but in negative direction. How to write a graph? See, so this is x, this is F, force of spring, right? Now as first case, displacement is positive, force is negative, force of spring. So displacement is positive as long as what is happening here, the force is negative which is increased linearly. So this is corresponding xm, let us say. Now how to calculate the area under this graph? You know very well, this is area right angle triangle. This is called as xm corresponding, and this is called as minus kx, which is force of a spring, negative direction, right. This is xm. Area under this graph is equals to half into xm into base into height. So kxm with minus, so minus of kxm square, which is called as work done by the spring. You can also extend this same graph here, right. This is f is equal to minus kx, right. This is work done by the spring. So how do you write work done on the spring? Simply it is opposite. Work done on the spring is kx square. Work done on the spring. Work done on the spring, right. Suppose it not only starts from zero position, sometimes in the middle. If you want to calculate how to calculate this one, suppose the spring is goes from xi to xf, not 0 to f, like final. How to calculate this? W is equals to right, this is f of spring into dx and xi and xf. So W is equals to xi xf minus kx dx. So W is equals to minus of kx square xi xf. W is equal to, if you apply this one, then you will get it as half k xi square minus half k xf square. So this is from one position to other position, work done by the spring calculated like this. Okay. And this, if cyclic process is there, cyclic process, what is the meaning of it? Initial position and final position are same, then what happens? Displacement is 0, right? Is 0. Suppose if xi and xf are same, work done by them is 0. So work done by the spring force is 0. So what is this? Shall I confirm that now this is work, if work done by the force in a cyclic process or in a displacement way, then what is this? This is called the spring force, is called as conservative force. A spring force is called as a conservative force. Now this work done by the spring can also be expressed in terms of potential energy stored in it, right. So now how to write this potential energy? Potential energy, I am writing it as of k x square. Potential energy is equal to of x square. Now I verify that dV by dx. Shall I calculate dV by dx? which is equals to, how do you write, which is kx. Now if you write minus dv by dx, which is equal to minus kx. What this represents, actually, you know very well, this is called as force. Force is equal to minus. You know that in the previous classes the conservative force can be expressed as a negative derivative of potential energy, like F is equal to minus dV by dx, right? Now what about kinetic energy? How to take kinetic energy? You can also see now when block like M is there, when it is being pulled right side and goes to xm position from x is equal to 0, and when this is going to this m, x is negative here, this is the compressed manner. So when it is going right side to left side, what is the velocity here? It moves with velocity. So it gains velocity also. If it is being compressed here, sudden release, it goes to extreme position, and at extreme position velocity becomes 0. At mean position velocity becomes maximum. So it also gains kinetic energy, where mass of the block is there, velocity of the block is there. The kinetic energy can be written as of mv square. If we want to calculate the total energy of the block, we should add kinetic energy as well as potential energy when it is oscillating between 0 to xm position or 0 to minus xm position. Minus x means left extreme, this is right extreme position, right? Now what is the energy? How to calculate energy, or what is the work done? So total energy, I am writing it as of k xm square, because this is called as total energy. How do I write total energy? When extreme position there is no kinetic energy, so of extreme k xm square is equal to the, if you write it, the total energy is equal to kinetic energy plus potential energy, or potential plus kinetic, however you can write it, it's not the big issue, right? So next here, so total energy is equal to potential energy of kx square, kinetic energy of mv square. It is a contribution of both. I can also write total energy right like this, of kxm square is equal to of kx square plus of mv square, right? Now I can also write the total energy in terms of only kinetic energy, which is called of mu max square. So this is a total energy one expression, and this is a total energy one expression. Why? Because here this has x is equal to 0, kinetic potential energy is equal to 0, kinetic energy is equals to maximum. So of mv max square. So from this, if you write this is equation 1 and equation 2, 1 and 2 are equal, 1 and 2 are equal, and here kinetic energy, total energy of mv max square is equal to of k xm square. So mv max square is equal to k xm square, right? Now I want to calculate maximum velocity, which is equals to root over k by m into x, or simply xm. This is maximum velocity expression. Maximum velocity expression. Compare the dimension analysis. How to write dimension analysis? So k means Newton per meter, and what is that? This m is a mass, kg, right? And take over root into xm meter. If you all calculates, then simply you will get it as meter per second, which is valid and verified with the velocity units or velocity dimensional formulas, right? How to represent simple format? Let us see. Suppose this is total energy. So this is minus xm, this is plus xm. So what is that? Kinetic energy. Kinetic energy, potential energy can be drawn. At a left extreme, velocity is equal to 0. Right extreme, velocity 0. So what about this one? Kinetic energy becomes 0. And reverse of that, let us see. Reverse. But left extreme or right extreme, what is that? Maximum extension is there, or this is compression. So potential energy is maximum, and when right extreme, potential energy is a maximum, right? So one is maximum, one is 0, one is other one is 0, other one is maximum. So, but at middle point, it is a contribution of particularly potential energy or kinetic energy. You can see that simple extension. This is, you can understand, this is like a block, and this is called as right side being pulled, which is xm. This is the block which is called a right side pulled, minus xm. This is, now this is a situation, right? You can understand here. What is this? It is velocity is equal to 0 at right side. What is this? This is velocity is equal to 0. Kinetic energy is equal to 0. Kinetic energy is equal to 0. Potential energy is equals to maximum. Here potential energy is equals to maximum. But what is this? At x is equal to 0 of kx square, right? Which is 0. Potential energy is equal to 0. Kinetic energy is equals to maximum, because here velocity maximum takes place, right? This is a simple analysis, and how this is energy converted from, replenished from kinetic to potential or potential to kinetic, we can say like that. So this also explains about law of conservation of energy, how energy is converting from kinetic to potential, potential to kinetic, or when kinetic is 0, potential maximum, or potential is 0, kinetic energy is maximum. That it can easily understand.